Good morning, everybody. Here's another example of an excellent crossover and synergies, to use that word, between the needs of my assistive technology users and my musicians. And when you really think about it, assistive or adaptive technology is for everybody. It's not limited to one group or another. We all rely on assistive technology one way or the other. So what I was working on originally was the unified trigger idea, and this is for my gaming folks, where pushing a dial forward would do basically acceleration and back would be brake, all in one device, and the device is spring loaded. Well, I shouldn't say spring loaded, it's not spring loaded, but it goes tilt that way, centers, tilt that way, centers, and I used magnets inside to handle that. So they're large. The magnets are large enough. This part is small enough, and they're close enough. And in the actual design, this has a ball bearing in there, so it's very, very smooth. Well, what came out of that? Well, actually, that originally came out of stuff like my musical dial stuff. And so this is a big one. This is a pitch bend and a modulation wheel for MIDI musicians, electronic musicians, and it snaps back to center like that. Now, in this case, started with a spring. So, and it still has a spring at this point because there's a lot of mass to move around. So, this kind of evolved into using it for the gaming, and the gaming kind of evolved for the music, and then the gaming evolved into a smaller version of the MIDI controller, which is a pitch bend, and this one it goes left and right. And the difference being here is instead of the spring that's in this big one, this is using magnets very similar to this one here, just a little bit bigger. So that kind of idea evolved. And then one of my users asked, well, you know what, could you do that kind of like two next to each other so that I could do triggers for my gaming? Now, the difference being with the gaming, with the musicians, they want the wheel to center, because what it is it's going pitch up, pitch down, and then zero change in the center. Where with like a car's accelerator, you want it to go all the way to nothing to maximum and return. So I took this idea from the music and I reworked it into this idea for the gaming. And so the same basic idea. So you have the bearing inside. There's a bearing inside, which you don't see here because it's not there. And you have the wheel part. Now, with the challenge here, I said, how do I get it to return to like a zero position? And I said, well, my good friends, magnets will work because they're good. If I set them up properly on the one end, they will attract each other. And so what I have is I have a wheel that will snap back without using a spring. So that's just magnets in there. And then I said to myself, well, if I go all the way to the limit, this is going to be too far of a distance for these magnets to pull it back. So I did the inverse on the other side. These two magnets repel each other. So as you move it towards this direction, they repel to give that little kickback so that it will return at least 50% to come back to here. And so far that's working real well. And because the repel is actually weaker, or it feels weaker, this is all relatively speaking, feels weaker than the attract, it doesn't really get super tough to move. It's about the same level of tension across. It's only when you get to the very end that you start feeling a little bit of pushback before it even hits the stop. One thing though is I found that the magnets I'm using are almost a little too strong. These are 6 millimeter in diameter and 4 millimeter tall, and I'm going to swap this out for a 2 millimeter tall, maybe on both, probably just on the base one, and that will reduce the amount of. It's a little too snappy. I was worried it wouldn't be snappy enough, and I end up with it opposite problem. It's a little too snappy. But the whole concept works. And you could see when I modified the design of the base part, I had to add this area to put the magnets in on the base. So this doesn't exist in these other ones here. And so they have two magnets, and these magnets, because of the angle that I have, the pie shape I have cut out of here, which I think is like 135 degrees or something, when you do the addition and subtraction and everything, this ends up needing to be about a 30-degree angle to have the proper pitch. So you can see it mates up pretty well between the two on both sides, and it has full clearance, so it doesn't knock into that center post at all either. It goes right to the limits. So this is really looking promising. I've actually run out of bearings, and I'm waiting on magnets, more of which I should have tomorrow, so I could actually build out more of these parts, because the idea, my goal here is I want to have like two of these next to each other. I'm not sure which way I'm going to have them. Maybe like that, mirrored together in an enclosure, and the enclosure would be a little bit bigger than this one, and it would be, I need to be deeper because I need to have some TRRS jacks in there, and a microcontroller, because I still need to read the values out of the rotary to a microcontroller, because this motion is not the full motion that this is capable of. So if you go limit to limit on this device, it'll give you the 10K resistance that you normally see on joysticks, but it doesn't go as far here. It goes pretty far. Well, it goes about a third of the range, I would say. So what happens is the microcontroller reads that and then converts it to the full range. So there we go. That's the fun with magnets and triggers and dials and pitch bend and all that. And it shows really how one product can influence another and influences another, and it goes back and forth. And that's one of the most interesting parts of my work, I find. Thank you for watching. I'll talk to you soon.